G'day guys, this is a follow-up from just that last live video I did. I was thinking about detector coils and so forth. And yeah, basically this is just a 5000 I did. This one is going to some famous detectorists that are also on YouTube. They've sent this in for upgrades and I've just finished it. And I'm just doing a soak test on it at the moment. I've got it sitting there humming away. It's in mono. It's on my cancel field coils up there at the moment. But I've got the door open with that massive big metallic whiteboard on it. It's unbalancing the coil probably because it's near one end of it. And I've also got the fan on because it's stinking hot here. Oh my God, it's been hot for the last 3 days. So hopefully it cools down tomorrow. It's very, yeah, very hot and sticky. It rained a little bit last night, and of course, what does that do? It just makes it humid, and I don't like humidity too much, but I don't care about the heat, just the humidity. I just don't like feeling sticky. I don't like that feeling at all. Anyway, this is yeah, 5. You'll see this on YouTube if you follow the guys who run around detecting and digging up piece of rusty metal all day. Not all the time. They do get some good stuff, but yeah, there's a lot of rusty metal out there, which brings me back to looking at the design of these detectors and actually putting in some how do we say it? We put in some FFT algo, and we can then manipulate what's coming in and look at it basically piece by piece and apply some smart mathematics to it, and we can probably more than likely discriminate about digging up metal. And you can do it with a monocoil too. Well, you know, that other detector out there does it, and that's why it was called algo force. It's a force of the algorithm. So same thing. I think DFT or FFT and maybe some adaptive filtering, we can come up with a very nice detector. I'm working on part of the detector at the moment, doing some overlays. I've got some other people doing the complex mathematic components, which yeah, basically we're going to look at everything with fresh eyes. I don't want to do it. I want someone else to look at it with fresh eyes that may pull something out of the woodwork that'll work really well. But yeah, there's a lot of development going on. There should be a lot of development going on with coils as well. Like I was saying, I did in that previous live video that um, there's a lot of scope to do with coils. Now, hopefully today, I better stop pointing at their head. I pointed at myself just for fun, eh? I'll loosen that off. Hopefully that doesn't fall down. There we go. You can see me here hot and sweaty. But basically, or not so basically, depending how you look at it. Let's move that back. I want to get over here a bit because the fan's blowing air in here. How's that? That detector was so quiet, and I've got the AC fan just, you know, not even a metre away from it. So it's knocking that out nicely. So, yeah, it's on full sensitivity and clocked very fast, sitting there in normal mode too, by the way. Okay, detectors, coils. There is so much scope with everything to do. You know, the more I've looked into this, you know, I've actually put some hard yards in doing some research. I've been looking at research papers, been looking at a lot of stuff. A lot of it to do with demining, because there's a lot of technical papers on demining. You can have a look at it yourself. Some of it you got to pay for. Some of it you can just get the name of it and then copy the name of it and put it in the search engine. We'll find it somewhere else. It'll be a freebie, usually on the guy who came up with it as a thesis or as just a research paper. So you get around paying for it that way. Not being a tight, but I don't want to go and pay for stuff that maybe it's got nothing of interest in it. Maybe it has. So we're looking at a lot of things. Well, I am. Just that it can be slow. One person trying to do everything. And the other thing too, which is might be of interest, that one of our customers, actually, he's not a bad bloke. He has done a bit of a deal with me. He's given me a brand new 6,000. Sorry, he hasn't given me the 6. It's his. The brand new one's his. He has, yeah. Well, he's given it to me, but there's another part of the story. But he's given me another detector, another 6,000, and the other 6,000. It's a bit sad. I'm not going to go into it, but he said if I do his brand new 6,000 up, he went and bought a brand new one, and if I do that detector, because I've done other ones for him, and he was really impressed. So that's a good thing. I won't go into the rest of the story, but he'll give me a 6,000 if I do his 6,000. So I thought that was a terribly good deal. The main reason is that not that I'm going to go run around the bush detecting with 6,000. I probably may do, but I'll probably use my 4,500. But not saying that the 6,000 is a bad detector, just that I've done so much work on my 45. I just like it. I know it so well. Dry throat. Too much talk, not enough drink. Yeah, so I'm going to do that, but the other 6,000 is a bit sad, and what I'll use it for is a test unit. I will be doing a lot of changes to that detector, and very carefully trying not to blow up the black module. I might put protection on that module on some of the inputs that I might use some nano fuses and stuff like that. That if anything does happen, it pops the fuse and goes open circuit. It doesn't take anything out, because in that black module you don't know what's in it. It's just a black blob with whatever it is, 30 legs coming out of it. You don't know. It's like you're not going to stick your hand in the gopher hole. And if there's not a gopher in there and there's a bloody big snake or something, you just don't know what's in there. So don't take the risk. So yeah, I'll probably getting that. I'll nut it out. I'll have to go and measure every pin and logically decipher what's going on with what's doing what. But eventually you can work it out. It's only logical what it does. Nothing really super special. It's got to have an in. It's got to have an out. It's got to go somewhere, and whatever's going out has to be doing something somewhere else. Maybe a lot of it's in that FPB processor. Dry mouth. Yeah, field programmable array, gate array. I should get something to drink. Yeah, I've been driving around with the air conditioner on in the car, come back in, the house is hot as, and yeah, air conditioners just dry you out. So yeah, talk about definitely dry. The rest of me's not. The rest of me's wet, but yeah, dry mouth. Yeah, even though it's humid, there's very little moisture anywhere, except on my skin, as you can probably see. It's just everything's just wet. But that's what we get. So yeah, I was just thinking about. There you go. I've got another project on. I've got to get the detector working first, because I think it had a bit of an accident. I think, I don't know, I haven't looked at it. It's just sitting out there at the moment. I've got to do the other one too. And I've got to do some other ones you can probably see up on the shelf there. Maybe if you can, I don't know, maybe, oh yes, there is. There is. There's more. David hasn't come in yet from post office. So he may do. I know he's got to pick up some over there that are done. So we, yeah, got to get them in, got to get them out, got to get them in, get them out. So trying to do all this is damn hard. I finally reassembled my own 7000 because someone sent the box in. I didn't have a head unit, so I had to put that back together. I was in the middle of doing a project with that as well. So yeah, it sort of stop start, and yeah, it's all coming together. So oh dear me, I just need I need a break. I tell you, must be still hot in the high 30s, and yeah, I've got an aircon top story of the house, but I haven't got one down the bottom. Normally you don't need it here. Ballarat's a cold hole of a place. You don't need aircon, but for some reason, the last few days it's been absolutely stinking and sweaty and muggy and just horrible. But yeah, I don't, like I say, I don't mind dry heat, but you know it's cloud cover. We've got a north wind, and it's just hot. So it is what it is. So anyway, what I was saying, I was thinking about coils. What I have to get made, I have to get some proper coil cable made. And when I say made, I don't want to buy existing coil cable. I'm not talking about Litz wire, what you want it with, but the actual feeder cable that goes from the detector to the coil. If anyone knows any reputable companies that make spiral braided Litz wire type coaxial cable, not coax like that, but the braid spiral down. If you ever look at one, you know what I mean. Let me know because I've checked a few out so far, and yeah, they can make cable for electric cars and stuff like that, but it's not what I'm after. I'm after a communication type cable. So yeah, there's one in there's actually a couple in Taiwan I've looked at. There's one in Korea. There's about 6 or 7 in China, but I think there's probably one or two I don't know about. So if you do know of any over there that make uh, you know good cable, I don't want to make in the ones that make cable now because cable's not good enough. It's not made properly. They try and skinny it down, and it becomes very high capacitance. They don't use the right dielectrics in it for what I want, and that means there's a pretty high dissipation factor in the dielectrics they use, and the loss factor goes right up. So I don't want that sort of stuff. I don't want to use um, what's already going around the neighbourhood. I want to actually get it made to my specification. I could probably get BAM back here to do it, but it'd be expensive as hell. Or even I could probably the people I trust mainly. I really trust New England wire and cable in the US, but our dollar is absolutely smashed against the US. It would cost a fair bit. So yeah, if you can utilize Asian companies, it keeps the price down, but there's always that quality issue. And yeah, I think definitely need to take that into account because I don't want to make things that are poor quality. It's not good. What else is there? What else is there? Well, if I get cable, I can make coils. Like I say, I got tons of Litz wire. Litz wire is not that critical. I found some interesting stuff out too with some of the other detectors. I'm going to do another video on that to do with their coils. That we've been hearing that there's been a lot of coils, especially a while ago. A whole heap of coils had the cables cut off and they're all thrown down the Bendigo recycling centre, or the tip as I call it. And when it was realised that people were going down there and buying the coils for $10 each or whatever they were selling them for, I think whoever took them down there had to race back and collect them all because, yeah, as far as I know, I think it was all 7,000 coils, uh, as I've been told. But there could have been some others in there too, and might have had the dongles in the coils. And if the cables were thrown in there as well, there would have been the communication chips in the coil connectors too, which would have allowed everyone to make their own coils really easy. But no big deal. 7,000 coils, it's not a problem. We have the dongle. So that's basically that's the dongle. That's got the little comms chip in that assembly, and you can just wire it up and using the right type of coil. Don't just use any coil. You'll end up with a big mess of blown up electronics. But if you do it properly, like I get David to make all these up, he does it for everybody. So if look at DetectorMods.com. If you want dongles made up out of your coils, just chop the plug off your coil, off your 7,000 coil, post in to David and say you want a dongle made so you can run X coils and even your own coils or anyone's, well, whoever else makes coils. Yeah, you don't need that magic chip in there anymore. You just use that. That's probably the reason why the 6,000 ended up with this inside the coil to stop people doing it. But as you've seen, you can hack the coil and rip the dongle out of the coil. So now that I've said that, and I've said it a few times, what's the next step? Right? Where are you going to put your dongle? As like it is just, it doesn't do anything. It's just a communication thing. It probably would say, I'm a double D, I'm a mono. But, there's other ways of doing that. Sense it off the coil winding wires anyway to the detector. It's just to stop people making coils. It's just to, in my opinion, just to jam the market up, right? So stop other people doing it. But like we've so far, Mr. X Coils has got around the problem, haven't they? And dongle X coil, away you go. And that's how they got around the problem. So I'm giving X coils a plug. And yeah, so all these methods that are used to thwart any sort of competition, really we just get around it because it's proven, isn't it? That's one way of getting around it. And the other brutal way of doing it is ripping apart. I'm going to tell you this because it's actually in my experience, this is 100% true. In my opinion, I'm going to say that, right? Because I don't want to be challenged by saying, "Oh, you said that, and we don't agree. We're going to go and wind you up in court cases and cost you tens of thousands of dollars." So it's just an opinion, okay? That a lot of these, I've come across probably about 3 of them so far. I'll have to grab it and show you what it is. These things out of that GPX14 that came out with the 6,000s, like I said before, I picked this coil up and I picked up one of mine and I said, bloody hell, why is this so light? And it's alloy. It's copper plated Litz type alloy. And that's what I found out when I tried to give it a good soldering. I found it very difficult. So I had to get the dip pot out and do it that way. But the other thing too, if this is where you got to be careful. You get this coil and you measure the resistance of this coil. Just the DC resistance, it's higher than a normal older GP, SD, or 4500, 5000 type coil. So these have higher winding resistance. The inductance is the same, but I think it might be getting onto about 0.35 or zero point 0.4 of an ohm. And the other cables we use, all the cables, the other windings we use about 0.2, 0.25. It depends on how many strands you got in it, but my coils I make are all very low, and I would be very careful about. Obviously, I've done this to get the weight down because I have. I've got the weight down, but they've sacrificed getting current into the coil quickly, uh, as it's very, very well. It's probably double the resistance, but it is what it is. It's not that conductive. So the other thing I found too, even if I pull one, this one I pulled apart. This is the one we pulled the dongle out. I won't mention what happened to the dongle, but um, overall, the way this was put together, the windings aren't tight, and that's what I found in that other coil, which is out the door at the moment. That when I was testing it, it was noisy and it was actually changing its ground balance point. And then I put the Coil Tech Gold Hawk coil on that detector, and it was a stable ounce. It changed. It did not move around in its ground balance point where we had this type of coil on. And I've got to say, it was a ratty looking coil. It looked like it'd been through the bloody war. It just kept changing ground balance point. Every time I tapped it, banged it, or whatever. So, what's going on? I'm not going to go pull a customer's coil apart and destroy it. Uh, so, I'm just going to tell him your coil's stuffed. And you can go and watch the video too, which I've done probably 2 or 3 videos back. That using your coil, mate. It was all over the shop. As soon as I put Mr. Trevor's Coil Tech, whatever it is, what is that called? Gold Hawk elliptical coil on. It just instantly behaved. So we've got to take that as it is. It seems believing. I don't think there's anything else that was causing the issue. But the Gold Hawk coil. I have never used a lot of Coil Tech coils. I was well, tell you the truth. When Nugget Finder first started, when Ryan started making calls, his old man used to make calls first, and I've talked to Barry. I used to talk to Barry a lot about coils, a lot about detectors years ago. I used to, we used to talk amongst a lot of people. Um, Jimmy Stewart's another one. Used to have a lot of conversations about coils and things. So, we knew the way things were going. But I've got to say, it's actually factual. First coil I ever got, I think it was made by Nugget Finder. I opened it up and it just had, well, it was for an SD2000. It was just tin plated wire and PVC insulation, which wasn't the best. But I think they have come a long way since those days. The coils are good now. They're good. They're properly made. So everyone's got to start somewhere. Have a think of the first ones that were ever made. Those fiberglass things. My God. If you ever broke one open, have a look inside that. You'd have a chuckle. Especially looking back with hindsight, you'd have a chuckle. But then they made, I'll tell you what, then they made those Kevlar flat type of coils. It's still a big 18-inch coil. It wasn't that clunky, loopy around the outside fiberglass coil. But those 18s must have come out with the 2200, I think, if I get it right. They are a damn good coil. I'd see people selling them cheap. There's nothing wrong with those coils. They're made out of proper Litz wire. They're done properly. They're not a resistive type, shorter turn type of shielding, which has been done on some coils. But it's made properly, and they're a damn good coil. I used to use one. Actually, I still got one kicking around, but I've had them as well, but I wanted the 18-inch shell because it was really nicely made, and I built other coils into it. But they were a good coil. There's not much. There's probably nothing at all in the performance of an 18 one of those to even get something made these days. There's nothing in it, unless they go and squash the windings out and they call it one of those flat, more sensitive coils, but you lose depth, right? Just remember that for a given target size, if you get maximum depth on a winding which is that equal that way and equal that way as it goes around the coil, you'll get a point of maximum depth. And as soon as you squash that out, you probably won't get that target anymore, but you'll get little ones closer in because the winding is like so, right? And because it's got extra windings here, well, it makes the coil that small. So that is generating the field from that small, trying to get down where that would have gone. Sorry, not efficient. You're trying to do everything all at once, and it's going to be broad, but it's not going to be the best for deep, and it's not going to be the best for small. It's sort of going to be in between, and sort of I don't know. It's like I don't even know how to explain it. It's NQR. There you go. But yeah, it's well, I suppose they made so many damn equal winding coils that they decided that they'll go and squash them out, and they said, "Oh, it's more sensitive to smaller gold." Well, yeah, it's a sort of smaller coil, but it's sort of a bigger coil. So it's trying to do both, but doesn't do either very efficiently because it's lost in the field. You can't do that. Believe me, you can't. You can, right? You can because they do it, but for maximum depth, the most just read a textbook, right? Just read it up, just pure physics. A square wound, equal height, equal width coil is the most efficient coil. And then you've got to get your winding spacing right. You've got to keep your magnetic coupling. You've got to get rid of your dielectric losses between whatever you're using, and you've got to keep it stable. And yeah, there's all formula for that anyway, which I have worked out years ago. I remember speaking to God, I'm going back years and years ago, but I remember I had a good conversation with one of the professors at the University of Surrey in the UK, and we had a great discussion about electromagnetic coils and all the experiments they've done. He gave me the whole gist of it for field densities on different types of coils. So I've done my own experiments over the years with that, and yeah, it's exactly as they said it was. But there's formulas to make a really good coil too, really good coils. So you've got to take everything into account. So do we say a heavy coil is a good coil and a light coil? There goes the dongle. A light coil is a compromise, but it's nice and light. If you weren't, in my opinion, if you weren't really serious, I suppose you use a light coil. If you're really serious, well, it's like the 7000 come out with a coil on it, a big coil that you need a crane to lift because it'll rip your bloody shoulder out of its socket unless you use a hip stick or something. I mean, Jesus, like this thing here. Oh, mate, get off there. Come here, you. Oh, God. Come here, you. That's it. I mean, swing that all day. This weighs, bloody hell, it is heavy. I mean, it actually sort of feels like it's made of lead. Uh, it's so heavy. Really, I actually had a 7000 with one of these on it. It actually come with this coil. And I think that's actually what cured me to get rid of it after about 2 days of using it. I was like, I can't use that. And oh, look at that. It just comes down. It's like massive gravitational pull on it. Boom! You just tell it's heavy. I wish I had scales I could measure it with. Oh my God. It's in the kilos for sure. Anyway, that's that. Then you got this thing here, right? Just fling it around. It's a nothing burger. It's light as a feather. It really is just light. So that is coils for you. You know, if you want to rip your arm out of your, or your shoulder out of its socket, you can use one of those big heavy coils. But I used all sorts of methods to swing that thing, and I said no way. And I used to go to the gym every day for about 20 years, and you know, um, I found it difficult. I could just imagine some retiree going around Australia, the missus swinging that thing around. My God, to cure you in 5 minutes. That's all you do. There's people I know out there who never be able to swing that in a million years. So yeah, light coils using. Well, I did say years ago about using copper plated alloys. Um, you know, and mm, I think there might be issues with it. Depends how the alloy is first treated to be plated. You can get micro cracks forming in the thin layer of copper plating, and I think that's what's happening in some coils, and they go noisy, right? I don't know for sure, just my opinion. If you want to strip it back, you can go and check that. But I think when you um, plate alloys, especially anything with aluminium or aluminum, whatever you want to call it, um, if it gets any atmosphere to it, it just oxidizes and things don't plate properly. So you got to clean it up and just keep the air away from it. Otherwise, it just goes pear shaped. So you probably got to keep dipping it in tanks of various liquids, to clean it and put a particular coating on it. I think there's a three layer process for doing copper on alloy, and I don't, in hindsight, by seeing other people actually doing it, I don't think it's that good of a good idea. Makes a good light coil. Don't get me wrong there, but I don't think it's good. Um, I don't think it's well, it's physically good, but electrically probably not. There is, like I say, even the resistance is up, and everyone will say, "Oh, but yeah, fast um, waveforms travel in the outermost part of the conductor." It's basically skin effect. But trying to dump current into it quickly through a resistive, or more resistive than copper alloy, um, does limit how fast you can get the current into the coil and out of the coil as well. So, that possibly may partially cause a little bit of a flyback removing problem. Don't know, haven't measured it. Um, just an opinion to throw out there. Try it for a bit of education. But yeah, yeah, if if you can make that out of imagine if you can make it out of silver, right? Not that you can't. I shouldn't say that because I bloody will try it. It'll still be heavy. Not. Oh, I don't know. Silver and copper are probably on par. I think. I don't know. I haven't looked it up. I don't know where it sits on the periodic table. I know it's more conductive. I don't know mass wise um, what the difference is. So you can look it up, then I'll know. But off the top of my head, I don't know. But you could do it out of silver. It'd be damn expensive. It'd be brittle. You wouldn't want to do it 0.125 or less size silver strands. Nah, it'll break. It'll just break. But you could do it out of copper and silver plate the copper. Then again, if you get any flaking, like micro cracks and stuff like that, it's gonna generate noise issues, and it's going to be all sorts of nasty stuff happening. So, in my opinion, when you make coils, try and stick to pure copper. I think if you do copper strands, and it's nice, soft, annealed copper, lay it all down properly, lock it up, tighten it up within reason, as long as you don't completely squash your joint together. Even in the cage here, look, you can hear that. You can I should write it down. So hard. So yeah, I think there was something clipped in here, but I don't know if the windings were that tight. I think they still could have wiggled around a little bit. You know, you look at other coils and they've done terrible stuff like pour resin in them. Don't like that. Don't like resin. It's got a terrible dielectric constant. Don't stick resin in your coils. Um, and I see it also, even other people's coils, especially on the, oh, dear me. People are going to hate me if I say this because, you know, I'll say the other coils, any coils, even the coils made for the 7000, I just look at them and this had damn epoxy resin poured into the coil windings, and it's like the biggest, in my opinion, it's the biggest no-no out there to do that. Don't do that. Don't put damn fiberglass resin. It's got a bloody dielectric of about 7 or 8 or something. You know, be very careful what you do. I'd use some sort of, I'd have it in there. I'd fluff it with some foaming stuff. You know, like a expanding foam, something like that. A lot of air in it. Don't dumb the coils down. I just shake my head. I really do. I see all this stuff and I just go, look at it and go, why did they do that? Why? What's the reason? Obviously, it's stability, because if you get movement in your coils, it's going to make noise, especially if you're banging into things. And if there's any flex or anything like that, hopefully you don't have flex in your coils. But just the methodology in locking up the windings in coils, there's better ways of doing it. You know, make I'm going to tell you how to do it. Make cutout channels bigger, lay the coil in there, and put in an expanding foam. Okay, let it expand, then trim it off. It's got tons of air in it. It's got a dielectric probably close to about 2.5. The coil will pick up better. It'll have massive stability. It's not going to move in a million years, and it just makes a better coil. Stop using resin, please. I want to see coils with no resin in them. And by the way, resin's heavy. So, you know, you go to all the trouble of using lightweight foam and that in your coils, and you pour resin in it. Don't do that, please. It's just don't do it. I don't like it. Well, I don't know. Maybe I should shut up. But it's made. It works, right? But you know, it's one of those things. I don't know. I suppose you could put a V8 in a larder as well, but I wouldn't put on the racetrack. There's a lot of things you could do that would improve the performance. So one of the things I was always very, very you know, interested in was, when I used to do microwave work, was dielectric losses in material, and used to, I've done a lot of study on it, and it actually is more or less the same for anything that has fast decaying waveforms, or anything. You're running at, or even you're pulsing these things at 30 kilohertz or whatever it may be, but you still got to remember about the target decay. What speed does a target decay at? Depends on the capacitance and the inductance of the coil, doesn't it? And also that gives rise to, what is the dielectric? What's the dissipation factor? Yeah, put it all together, and it'll give you your loss tangents. So maybe it's good enough as is, but if you want to make a really good coil, you can do a lot better than the way these are done, especially when I'm not going to go on about it because it's just stupid. It's not stupid, it's probably tedious, and you know, everyone will think I'm a bit of a, you know, a C something, we're ending in a T or something, you know, before saying it, you know, especially commercial interests, that I'm saying something bad about their coils, but I didn't mention any brands today. So yeah, but there's many a way to make a really good coil. I've made really good coils, and I've done really bad coils on purpose just to prove it too. Like I made that experimental coil, and I just made out of tin plated wire, and I used Teflon insulation, which has a dielectric of 2.2, and one third diameter of wire conductor uh, spacing to the next one, which is about optimum. And when a coil, and even though it's nowhere near as good as Litz wire, it just can't be. It was so damn close, it wasn't funny. So it was just to prove that just using tin plated multi-strand wire, you can get a very, very equivalent result compared to a so-so made coil. It's not much in it. It really isn't. You probably getting a difference. I don't know, about 5% difference. So, but then again, if you then use Litz wire and made a really good coil compared to existing coils, you can probably get about 10% improvement, maybe more. Especially looking at some of these, what do they call them? Super D coils. I'm not saying the manufacturer, could be any. The way it's done is not optimum. I want to say that it's not optimum. It's not. So, you know, that will probably equate to people walking over gold nuggets, right? Not being optimum. There will be losses in the transmit field, and there will be losses in the the generated field from the target going back into the coil, into the receive windings. If you got losses there, bye-bye signal, you're going to go down below the noise floor. You're not going to be able to hear it. It's going to diminish. So, I'm being pedantic, of course, but it's true. It's like if you're going to do Formula One racing, you're going to go and sit there and tune everything perfect because you want to win the race. And same with metal detecting. You don't want to go out there with a slug of a vehicle to try and win the race when everyone else has been around the racetrack before you. So you want something better, don't you? You want something that's going to perform a bit better. So anyway, this for the hell of it, I just want to disconnect this. This I'm not going to show the other side of it because it's got the name on it, but they know who they are. Come here, you. Bonk. So that one there, and it looks like it's actually very, very newish, doesn't it? Very, very newish indeed, but it's not really because it's got dirt on the front. So, yeah. So that one has to go back to the owner. I don't know which one of the two is the owner, but you know who you are. You make videos. The two of you make videos and put them on YouTube. I watch your videos, by the way. I think they're quite entertaining. So when it goes back to the owner, maybe they can say what they want to say about their upgraded 5000, and then I'll point everyone to the video so they can watch it. So if they don't like it, I won't point you to the video. If they do like it, I will. No, they'll like it because it works really well. It works far better than the standard one. So much quieter, hell of a lot quieter, and very sensitive, very sensitive. And I've tested it the worst ground balance scenarios, and it just eats it for breakfast, doesn't care less. So it'll work really good. So that's going to go back. And for the time being, rather than doing other detectors, I'm going to get this 6000, the one I have to do, and the one that I've been given as a method of payment for doing the other 6000. So it's going to be good because we're going to learn a lot. We're going to learn a lot by having a 6000 that I can really get my teeth into. There's some parts in the 6000 I want to replace, and I'm not going to go and say what to replace just yet. And I don't know if I ever will because it might be so damn good I want to keep it a secret. I don't know. We'll see how we go. But there are some parts in that 6000 I do want to replace. I just got to make sure that you've got to be careful with this thing because it's not really made to be worked on. I'm still waiting on my cable connectors to come so I can separate the boards and have the thing running on the bench so I can get on to both sides of both boards. That's the other thing too. And yeah, I'm going to probably make a lot of discoveries with that detector because just doing a few things to it, it greatly improves it. You know, like I say, just have a look at the videos where the people have had it done, and they make comments on my videos with the 6000s there. And I'll tell you, ask them yourself. Send them a message. Um, so yeah, I can't add to that. I'd rather just get the customer feedback. Customer feedback, put it up there. You know, you don't like it, say so. Um, Also, if you don't like it, send it back to us and say what you don't like or what it doesn't do. You know, if you've got an issue, and you know, like I say, most of the time I do get them back. It's usually something else, like like dodgy coils and stuff like that. Or I've had it before where a guy sent the detector in and said, "Oh, it's all horrible. The audio's his bloody battery audio amplifier had packed it in on one side of the circuit. It is sort of a differential amplifier in there to keep the noise out of it, and one of them had died, so it was sounded like, you know, grating fingernails down a chalkboard." And said it was the detector. They sent everything in, it's not the detector, and it was the battery. So one of those little five-legged op amps, which has V&A written on it, had died, I think, if I remember rightly. So I can't remember the real part number if you want to fix them, but they're available. I think TI part for memory. You know, it's not my interest fixing up amplifier boards and batteries. So maybe what I'll do if I ever find one. Well, I've got one on the bench actually, but it's a knockoff, so I'm not going to do it on a knockoff. It's a Chinese one, but it's exactly the same circuit. They knocked it off exactly the same, and yeah, I actually didn't like the way I didn't like the way it sounded, so I actually bypassed the audio amplifier in the battery, and I used my own boosted one with that compression and expansion on it as well. So I can, you know, bunch up the dynamics, or I can expand it out depending on the situation. So yeah, I said I made a good booster. Put a lot of work into that. So anyway, yeah, I said Chari make up another batch of them because we run out. We don't really push it, and it just gets around. Like our headphones we made as well. I don't push that anymore because they just keep flicking out the door. I see PayPal orders coming in all the time. You know, same amount. So I know it's headphones, headphones, headphones. David looks after all that. I don't do it. I'm just doing all the, you know, all the intricate stuff. Yeah, the other thing too, I've got to change my oscilloscope over. I've got to get, damn it, I've got to go and use that bloody LaCroix thing I've got. It's got FFT analysis in the oscilloscope. We're going to start doing FFT stuff, and I need to actually look at that. I can't do it on the Tektronix one, even though I love using it. It's got a 350 megahertz analog bandwidth. It's a fantastic oscilloscope, and great for doing detectors. I'll tell you what, right now, I had some detectors. I had small ones I was using. They were Tektronix still. I had digital ones, 50 megahertz, 75 megahertz, 100 megahertz, 150. And I was actually looking at some artifacts on the receive signal, actually in switching. And I was looking on those. I knew it was there. I could hear it, couldn't see it. And then I got this, what is she? I can't remember the number of it. It's a 2465. I think it's got a bandwidth for 350 megs anyway, analog scope, and good persistence on the screen. And straight away, these are artifacts. You can see them. You turn the brightness up, you can see them. On the digital scopes, what's that? They don't even know it's there. And then some of the digital scopes generate their own artifacts because of the way they do things. I think it's a bandwidth limiting thing, and starts aliasing and goes pear-shaped. But But anyway, I don't want to go into that too much. But yeah, I've got to get my 1.5 gigahertz uh, digital crow, and because it's very high bandwidth, even though it's a digital crow, it still catches the glitches. It's quite good, but it's got noisy fan in it. That's why I just took it away because it's got a lot of high speed chips in there. It's got to keep it cool, and oh, God, I wouldn't want to run on a day like today anyway. Probably melt. But yeah, it's just noisy. I wonder if I could, if anyone's got one of those LaCroix fast crows, I've got a better way of cooling it where I can, put more air through it, but slow the air velocity down or something. Let me know because it's just sits there. I don't know, just it's a constant whir. If I have that other one on, don't even hear it. Fan's going, but you don't hear it. It's really quiet. So yeah. Anyway, that's enough waffle on that. So I'll get one 6,000 done as I meant to do, and then I'll repair the other one, and then we can have some fun with it. We'll go and do a deep dive on every part of it, and I've got to obtain another dongle so I can use different coils on it, and yeah, I've got to be careful too because I've actually got to have a good look at the circuitry just to make sure that if we put a lower resistance coil on the detector that it doesn't cook the transmitter or something like that. Who knows? It might have tripwires in it that you do that. It ET phone home and blows up or something. I don't know. I hope not, but you never know because I don't know. I have never delved into it at that level because you don't do that on customers' detectors. You want to do it on your own. That's why I've got my own detectors. I've got my own 7,000, my own 2,000, 2,100, 2,200, GP Extremes, 3,500s, 3,000s, whatever. I haven't got a 48. Don't need it, but it's much of a thing with a 4,500. And you got a 5,000, covers all bases anyway. So now I've got a 6,000 and like I said, 7,000. And yeah, we'll start ripping right into things, get right in there. The only thing is, I'm not going to do it today because what's going to happen if I do it, I reckon I'll drip sweat into it, it'll blow it up. So salty sweat's conductive. You don't know what's going to happen. You don't want to do it. Don't drip sweat in the circuit boards. Not a good idea. Speaking of that, someone, I won't say any names, I went to one of the fast food places and got some burgers and 4 Cokes in those papery cardboard cups, the plastic clip-on lids, and they put it, I didn't realise it because I'm just getting it through the window. I say, here, to the person sitting next to me in the car, here, and they put it on center console, okay? And then they put the armrest down to hold it in place. And when they got out the car, they pushed on the armrest to get out the car for leverage. And I saw it, and it pushed down on one of the cups and crushed it down, and all the Coke went through the center console of the car. And it's a Range Rover, okay? And the center console has it's got a bloody computer board in there. And what happened is the Coke went all down through all the switching for different modes for the traction control, everything, right? Up, down, all the different, off-road capabilities and that. And it started bringing up error faults, right? And even one of the switches failed and locked, and the car went into limp mode. I'm going, oh, no. And anyway, I had to pull it apart. I did it yesterday, pulled it apart, and got right in there. And I didn't expect, I thought it was just in the wiring loom, but no, there's a computer board about that big in there, and it's got a micro on it. It's got a whole heap of little touch things and light pipes and all sorts. So I had to get that, and I cleaned it up with isopropyl alcohol, did the looms anyway, put it back together, and the bloody fault stayed there. And I went, oh no, it's going to cost me for a new board. It cost a fortune. Um, and yeah, I fiddled with the car, and it was coming up error. It wouldn't do anything, and it was, dinging away, doing crazy things. And basically, what I did, I just disconnected the car battery, put it back on, and the faults are gone. So it was just there's a fault retention because it had been upset, that it was saying, basically saying, take me to the dealer so we can rip you off. So yeah, if you ever have stuff like that happen on these weirdo cars, just pull the battery connection off. Don't do it on an electric vehicle. You might get 400 volts up your jumper. But I'm talking about diesel, petrol, gas type cars. Just pull off the starter battery and let it sit, and then put it back on, and all the faults cleared. So I've been everywhere today. It didn't die. So that's good. And actually, the car's running better. It's got more power. Don't ask me how that is, but maybe it's the warm weather. I don't know. It's just got more oomph to it. And I found another thing about what they do with these Range Rovers too. To get through the emission criteria when they get tested, did you know when it's on idle, right? If you've got a 6-cylinder one, it runs on 5 cylinders. Didn't know that, did you? Yeah, so it doesn't. It puts out less noxious whatever's in the exhaust, and that's why they're a bit of a slug to take off sometimes. But there's someone out there who does a software change, probably illegal. Then it goes against the emission standards, doesn't it? But it actually makes it run on 6 cylinders at takeoff. And yes, it would definitely run better doing that. But yeah, so there's a whole heap of stuff they do. All this anti-emission, rubbish. Shove the exhaust back into the engine. I don't do that. My one, I got the last good one where they didn't have all that bloody emission control stuff. So you don't need it, yeah, you can blank it off because it doesn't come under the legislation at that time when the vehicle was made that it has to comply. So yeah, so my one runs a lot cleaner than anyone else's. I think it, you look in those areas there, and it's just full on a normal one, because I looked at David's old one. It was all full of soot, and you could just scoop it out with a spoon. It clogs the whole thing up, and probably destroys the motor after a while. So yeah, I don't like a lot of the new diesels with all their anti-pollution. Yeah, doesn't make much difference anyway. You know, crazy overkill. But yeah, anyway, waffle. That's if you've got a Land Rover or a Range Rover or whatever. Now they'll probably, it's just my opinion, okay, to whoever make those things. My opinion, my own experience. Yeah, okay, that's enough. Don't want to go talking about vehicles. I want to get this other thing done, so I'll be probably working on it like this so I don't drop sweat in it. No, I'll get the fan, get it closer, and blow cold air over myself, and so I don't sweat. Anyway, catch us, guys.